Hi everyone, in this video I'm gonna talk about ESPO's new product, which is designed to give you the ability to have iterative runs in EMTP-RV program. In fact, EMTP-RV is a complete program for simulating transients. Still, there is a lack of iterative run when so many cases are necessary. Anyway, this is the installation folder. As you can see, there are 6 files here, of which 2 are .exe or their type is application. The ESPO fault device is the main application that contains the designed library for EMTP-RV. Let's go for this one first. Its setup is so simple. There are just a few points that we should consider during its installation process. At the first stage, the welcome page appears. I'll click on next. Then I ask to enter the serial number. It is available here in the installation folder. I just copy the numbers using Ctrl+C and then paste them to the corresponding boxes using Ctrl+V. Like this. And the second one, third one, and the last one. Then we should select the installation folder. Please note that it should exactly be your EMTP-RV path. It is also mentioned here in bold font. Otherwise, the designed library won't work correctly. And finally, we should click on install. It might take a little while. Okay, it's done. Let's check the EMTP-RV directory. I pinned it here. As you can see, a new folder named ESPO has been added here. And the folder contains our library that we should add it to EMTP-RV. Well, let's do this. For example, I want to have a new design. Now from the options tab, I should click on the library operation to add my library. There are 2 options available for me in this stage. The first is to permanently add our library using the last option, auto open libraries. We also can use the second option to open it just for this time that we use EMTP-RV. I select this one, for instance, and then we can choose our library. As you can see in the program's library, a new category named ESPO_lib is added just right here. There are 2 devices in this library. One is fault device, which is the main device that we should use. I drag it to my workspace. It has just 1 pin that should be connected to the place where we want to simulate our fault. For example, I want to simulate some faults in the middle of a transmission line. As a result, I'll add 2 CP lines and place them on the sides of our device. Then we need to connect them. And since it's just an example, I don't change my lines parameters. In fact, we just want to test whether this device works or not. So to make our circuit simple, I'll just add a source from here. This one, for example, on the left hand side, and a load, for example this one, on the right hand side. We also need to equalize the voltage levels. And then we should specify our desired outputs. In this regard, we can use the meters library. I want to add a voltage meter as an example next to my source, right here. Okay, our circuit is ready now. If it was a normal circuit, we would use the run button from the simulate tab. It's just here. But the ESPO fault device has its own run button. It's in our library. I'll drag it to my workspace. And the final thing that we need is the unplug button. It's a necessity for the designed devices, and you should bring it from the options library. Otherwise, you will get an error. Well, our circuit is completely ready now. We just need to save it using Ctrl S. For example, here. And now, after clicking on the ESPO fault run button, an input box with 5 fields will appear. Let's check what they are. The first field is related to your wished fault resistance, or I should say fault resistances, because you can insert a list of numbers here. They just should be in a bracket, and also each number need to have apostrophes on both sides. The next field is for fault inception time, and the third one is for fault types. I'll leave these fields unchanged because we just want to see the final result. The next field is related to meters. There are some explanations about how to specify our meters here in the device documentation, and you can access that documentation by double-clicking on the main device. Anyway, in this case, these values here just fit with our placed meter, so I'll leave them unchanged too. And the final field is the file suffix. You can write whatever you want here to highlight the other features of your faults. For instance, I want to write 400 kilometers here so that I'll remember these faults are simulated in the middle of our transmission line. We can click on OK now and it will simulate the faults for us. But before doing that, I want to install the other application. It's the optional extension and give us the ability to control some tasks during the iterative runs. Its setup is so simple. Besides, you can install it wherever you want, so I will install it here. Well, the installation is finished. Since it's an independent application, it will be added to your application in the start menu. You can easily search it. It might take time to open it for first time. In addition, you need to specify your EMTP-RV path using the browse here for the first time that you use this application, and then all options will be enabled. There are three options available in this version for controlling the ESPO device. These are output file type using this toggle button group, stopping the process and pausing it. For example, we want to change our output file type to text. Now I can get back to EMTP-RV and click on OK. I can cancel it for now, and as you can see, the EMTP-RV is running now. However, as it is mentioned here, there are a total of 275 cases that we defined for this study. We don't want to wait all of them to finish, so as we discussed before, we can use this button to stop the process. Here it is. You can see it worked. Now let's check the circuit folder. Well, it seems that we made it. I want to open one of the simulated cases as an example. As you can see, there are a vast number of values in different columns. You can also determine that each column is related to what parameter using the label files. Based on this file, the first, third, and the fifth columns are related to time, and the other ones are voltage of different phases. All in all, we observed that we can simulate how many cases we wish using the designed ESPO device. If you find this video useful, please subscribe to our channel.